So now we're going to actually start looking at some very important theorems. We're not actually going to prove the theorems completely formally yet, but we are going to do a transformational proof, which is going to be fairly convincing, and it will be good enough for us right now. So let's take a look at theorems that relate parallel lines to the angles that are formed when they are cut by transversals. So the first theorem has to do with corresponding angles. And we're going to take a look at a diagram here where A and B are parallel lines, and it's given that they're parallel. And then we have this line MN, like we had above, which is a transversal that cuts the two lines A and B in points A and X, just like it did above. And then using patty paper, we're going to do some translations, we're going to do some rotations and translations, and we're going to look for relationships between these angles. Now let's take a look at the first problem. Trace angle 1 on patty paper. So let's go ahead and do that. Let's take our patty paper and let's trace angle 1. We've got our line MN. We've got our two parallel lines. In this case, they're A and B. Okay. And so we are supposed to trace angle 1. Well, that's right here. We'll call it angle 1. Translate point A to point X along line MN. So now let's translate from this point to this point along this line. So we can see through our patty paper that we're sliding along the line until angle 1 now lies on top of angle 2. What can you conclude about angle 1 and angle 2? We'll take a look at them. Angle 1 and angle 2 look like they're lying right on top of each other. In fact, they look congruent, don't they? Okay, if you look at them through patty paper, you'll see that they seem to be lying right on top of each other. So corresponding angles are congruent when a transversal intersects parallel lines. Okay, so remember that the statement in this case that we can conclude is that angle 1 is congruent to angle 2. So let's say we have angle 1 is congruent to angle 2. That would be our particular statement in this case. But to generalize, we could do the same thing we did with angle 1 and angle 2 with any pairs of corresponding angles. So the generalization is going to be that if lines A and B are parallel, then corresponding angles are congruent. Okay, so we proved it for 1 and 2, but using this transformational proof, we could prove it for all corresponding angles. Well, let's go down to our second problem here. Okay, again, we've got the same line MN, we've got the same points AX, but we've got two different angles now that are labeled. Angles 1 and 3. These are now alternate interior angles, aren't they? 1 and 3 is inside the parallel lines. 1 is on the right side of the transversal, and 3 is on the left side of the transversal. So they're alternating, but they're interior. Let's go ahead and let's trace angle 1 on patty paper. Well, we kind of did that already, so let's go ahead and just make sure it still fits this drawing, which it seems to fit very nicely. Your patty paper should fit as well. And then what we're supposed to do is rotate angle 1 about point A 180 degrees. Okay, so let's do that first. Let's rotate around point A 180 degrees. So we still have the line. Remember, the line is going to end up on top of itself again, but we're going to have stuff flipped over. So right now, we've done that. We've rotated at 180 degrees. What's the next thing we need to do? Then translate point A to point X along the line. Okay, well, point X is down here. We can see it through our patty paper. If you take a really good look, Maybe on yours you could see it. I can just sort of barely see it right there. So now along the line, I am going to rotate the patty paper down. And now I've got the O point A on top of point X. What can you conclude about angles 1 and angle 3? Well, take a look. Now angle 1 and angle 3 are lying right on top of each other, aren't they? And, in fact, they're congruent. As you can see, they certainly look congruent, very close to it at the very least, and we will be proving soon, in a couple of days, that actually they are congruent. So the conclusion in this case is that given angle A and angle B parallel, and given this labeled angle, alternate interior angle, we can say that angle 1 is congruent to angle 3. And in general, we can say alternate interior angles are congruent as long as we know the original lines are parallel.